Alrighty, today we're going to start with a Fusion360 tutorial on component libraries. I have a blank project open here, and we're going to go to the File tab, New Electronics Library, and it'll open this pane here that is your content manager. You have components, symbols, footprints, and packages here. Up at the top you have create new component, create new symbol, create new footprint, and create new package. So we're going to go ahead and create a new component. We're just going to call it, let's call it a resistor. And within this component library, you can add multiple components for future use. Just keep it all under one electronics library. So go ahead and save that. It's good to save often. Demo library. We're going to throw a couple A's in there just to make it easy to find. Now that we have this, we need to create a symbol. We have none, so we can go up here to create a symbol. Call this a resistor. And now that we're in the resistor menu or environment, we can go down here to the grid settings. We want a 0.1 inch size, but we can hit the Alt key for a 0.0, let's go 0.025. Do that. Now we go up here to the pin, and we can place it somewhere about here around the origin, and you double right click to rotate. Now we get out of there. And we want to name these pins something. So we can go up to this name tool, name it P1, or we can go down to the info tool, and that'll pull up all the properties. So we'll name this one P2. We're actually going to need this info tool to change the visibility of its pin to only pin and not the pad, and you'll see why later. So go to the other one, make sure that one's also pin only. Now we have two pins, but you're not going to know what that is on a schematic. So we need to add a line. Just go around here. These are the settings that go with, and then you can hit escape key to get rid of that. Go ahead and save. That way you back up to the cloud. Now we're going to go down to this drop down menu. You go to names, and then you hit text, and now we can give it a location to name your component. So we're going to go name. Default settings are fine, but we're going to put it right in the center, so we're going to go with bottom center. Go ahead and use that Alt key to go around here, and I just realized we're not centered, so we can go ahead and left click that. Sometimes. Move that. Move that. Now we're fine. We're going to go ahead and add a value. So we go to the values drop down and then go to the text tool. We're going to go ahead and put value like that. And then we can do top middle. Use the Alt tool to fine tune it. It goes right there in the middle. So that's the schematic symbols. It's pretty simple. If you have a integrated circuit or something with multiple pins, you can use this pin array. That will give you, base name, certain pin count, and a couple other settings. And Fusion's really good about having these layouts to make stuff self-explanatory. There's also a pattern tool, but I don't use that very often, if ever. But now we can go and save that. All right, so now we can go over and look at our footprints. We don't have any, so we're going to create a new one. We're going to call this a 1/4 watt plated through hole resistor. And based on that name, what you can guess is we're going to be using plated through hole pads instead of the surface mount. There's also the same thing with the arrays if you had like an IC. We're not going to use that today though. we're just going to use these pads. We want a circular pad. They also have octagonal, these longer ones, an offset one, and slots. But I'm just going to use the circle one. Auto for the annular ring is fine. And we want our hole size to be 29.5 mils. And mils is just another word for thousandths of an inch. And you'll see why that's important later. But go ahead and put 2 there. Now we need to figure out hole spacing. Right now our grid settings are these, and I'm actually going to set my alternate to 10. 50 mils, so that's 5/10ths of an inch. If you go ahead and click on it, hit info, you can also see where its location is. And we're going to have a spacing of 8 millimeters. Now you could go ahead and do the calculations and it would be, let's see, we're in the negative space, so 157.48. There's a decimal in there. That's how many thousandths of an inch are in 4 millimeters, because we want to center it around the origin. That would be fine. Apply that, it goes right where you want it. Or Fusion is great because, if you click on the right part, Fusion's great because you can just enter millimeters. It can detect what unit you're using and change it for you. Boom. So now you need some sort of way of knowing where that component is going to be on the board. So we're going to use a line. We're going to go something like that, not too specific. We want a line of 6 mil, should be fine. Let's go find our info tool, sorry. Not that one, that side. All right, so this is this left plane. We're gonna go do a 6 by 2.3 millimeter rectangle. So we're gonna go 3 millimeters here, 3 millimeters here. Actually, yeah, that's negative. And then up here we're gonna go 1.15 millimeters to negative 1.15 millimeters. And you'll see it looks a little funny until we go to this other side. That's going to be another 3 millimeters. And go negative 1.15 millimeters and 1.15 millimeters. The other thing to look at is, you see how it's green? Up here with that drop-down menu, we're still stuck on pads. So we need to change to top place. That's your layer for the top silk screen. We're going to click on that. We're going to change it to the same. Click on that. And on the same layer, we're going to give it a name. We can go ahead and top names. Go ahead and add the name. And we're going to go to 40 thousandths of an inch. And go ahead and center it. Perfect. And space on a circuit board, your components ideally are as close to each other as possible. So we're not going to bother putting the value on here. You should be able to reference your schematic and figure it out on your own. If there's a particular part that has a specific value you're concerned about, you can add that later in your PCB design. But we're going to go ahead and save that. And now we're going to move on to our package. And in order to add a package to this specific part, since it's already made in our footprint, we're going to right click it and say create new 3D model. go ahead and name it the same thing, doesn't really matter for this. And it'll give you an outline of that footprint for your circuit board. So they have this package generator that we will explore a little bit later, but for right now, we're just going to go to solid and act like a regular 3D component. We're going to start a sketch here on this plane, zoom in a little bit, and we're going to make a couple of rectangles, just like that. And you can see that this is the ground plane. That's where our circuit board is going to face. So in order to dimension it properly, remember, don't use chain dimensions, always have a reference. So from here to here, we want 3 millimeters, and your 3D environment defaults to millimeters anyway. From there to there, we're going to do 1.5, that way they are equal. And from here to here, we're going to go 0.8 millimeters. It's okay. Let's move that down. Go to sketch dimension, and this one is going to be 1.15. Great. So we have half of our resistor. It's still floating around in space, so we're going to go ahead and do a collinear constraint. Go with that axis, and we can't hit this axis. We know it's the z-axis based on this little box in the right. So we can go to origin and select z, and now it's constrained to the z-axis. Go ahead and escape to get rid of that. Save often. And now we're going to go ahead and mirror this. So we can just kind of highlight everything. Right now it doesn't matter. Mirror line. We're going to select that. There we go. And we see one big thing. And it includes this area, but we're not going to worry about that because we can go and finish our sketch. I'm going to go ahead and hit home so you can see the 3D view of it. We're going to revolve it. And Fusion is great because you can select independent areas. And if you want to deselect something, you hold the control key and deselect it. So now we go ahead and select our axes. That's this one. And boom. And we're going to go ahead and add a fillet to all of our edges here. And add a 0.2 millimeter fillet. So that's getting close to our shape. Now we have to somehow add the leads. And we can go ahead and create a sketch here. And down in the Create menu, there is a section called Project and Include. I like to use the keyboard shortcut of P, just because I use this tool so often. You select a surface, you hit enter, and it gives you the geometries to reference in your sketch. We're going to go ahead and use that center point, and we're going to add a 0.4 millimeter circle. Go ahead and finish that, go back out, and we're going to create another sketch here on the same plane that we sketched the main body of the resistor. We're going to go ahead and add a line coming out, but first we have to project that geometry. Go ahead and project the geometry of your footprint. That way you have a center point there. Hit OK. I'm going to go back. Add that line there. Escape. Add another line. Escape that. Now we need an arc. We're going to use a 3-point arc just because it's easy to use. We're going to go ahead and put an arbitrary radius on that. Turns out that is tangent right there, so we're going to go ahead and put a tangent constraint there. Hit OK. Dimension that to 0.4, and that constrains that entire body. Now we can go ahead and add a line here of 2.6 millimeters. And it's 90 degrees, so it's not going to go anywhere. Go ahead and finish the sketch. Now we have a circle here and a line here. So we're going to go ahead and under Create, there's a sweep tool. So we're going to select this geometry and we're going to have it follow this path. And we're not going to join it. We are going to create a new body. Go ahead and add a chamfer to this edge. That chamfer is going to be 0.1 millimeters. And now we have one of the leads for our resistor. We can go ahead and go to the Create section, find your mirror tool, and you can either select the body or you can select the physical object. And our mirror plane is just going to be right here in the middle since we're centered around the origin. Go ahead and hit OK. And now we have two of our legs. Now's the fun part where we can go ahead and modify and select a physical material. And under electronics, we grab discrete component. Under metal, we can scroll all the way down to this tin, aluminum, copper. I like to use this for my component leads or any sort of metal contacts on an electronics part. I think it looks the most realistic other than gold contacts. Now we can close that. Go ahead and find the appearance tool. And under plastics, these type of resistors either come in blue or beige, so not being able to find a blue on here without making a custom color, I've picked this PAEK plastic that is a beige color, and it looks good enough. So you can be done with your component here, or I like to get a little bit extra fancy, and we'll speed through that real quick. Alright, now we have a little bit more realistic resistor here. We can go ahead and save that. And now we can go ahead and go back to our library. If you click on that, you'll see the 3D package now. Go ahead and save to make sure it's all coherent. And if we go back to our resistor, still nothing here, but that's okay. We'll get back to that in a second. Back to the package generator, we can create a new package. Go ahead and either select package generator or it may pop up automatically. And what we created was an axial resistor. There are many types of packages for electronics components. A lot of them are surface mount, like this chip LED. There's some dual inline packages or DIPs. Surface mount capacitors, standoffs, pin headers, LEDs, transistors or some sort of regulators, variety of things. But what we're interested in is the chip resistor. They also have ferrite beads, fuses, inductors. A lot of stuff comes in this package. We want a rectangle pad shape. And our L is going to be 0.1 millimeters at a minimum and up to 0.5 millimeters. So that's this dimension. And L1 is going to be the same on the other side of 0.1 and 0.5. Our D is going to be 1.4 at a minimum and a max of 1.7. Our E is going to be 0.65 at a minimum and a maximum of 0.95. And these are specifications that are in the data sheets for these components. What we're making is a 0603 standard resistor. Not too complicated, but your A is going to be 0.6 millimeters. And you can kind of look around. Also, a nice feature is if you've made a part before, and you click on these three little dots, it will show you your previous dimensions. If you had to make a custom footprint, this is where you would do it. You can also have manufacturing tolerances. Go ahead and add that, and it automatically creates that part. That's your 3D CAD, and it will save the footprint for you. So we go ahead and save that. We can call it R0603 and save that. All right, now we can go back to the main library. Go ahead and save again because that part is being updated. Under components, now is where we build the actual component and make it one whole file. Go ahead and add. You add your resistor symbol. We're going to put that about the origin, just like that. We can go ahead and hit info, click on it, and change this name. We're going to go with R1 is our starting point. That's what that $ signifies. So now we can go down here to the bottom, hit new, add a local package. We're going to add our 1/4 watt resistor. We're just going to call it 1/4 watt and plated through hole, or PTH. Now we can go ahead and connect the pins. So these pins here to the footprint pins. We're going to connect 1 to 1, 2 to 2. It's a little more tedious on bigger parts like IC packages, but not too hard here. We're going to turn the values on, so that will show this value on your schematic. Add another local package, R0603. Go ahead and add that. Values are on for that. We can go ahead and connect the pins. We made them in line, so they should just line up like that. And go ahead and save your part. Now with our component finished, we can go ahead and go to the File tab, and create a new electronics design, create a new schematic, and under the Place Components, we can find our library and select the variant we want. So I'm going to select both types as a quick test. Up there, select the other variant. Go ahead and double click to place that. Close that. And this part, we can go ahead and go to the info. We're just going to call it R1. Not that. Call that one R2. And within here, we can either change the value. So I'm going to say 10K for this one. Or we can go ahead and use the value feature. So this one's going to be a 5K. Now we can go ahead and switch to a PCB design. And you'll see the components down here. So we can throw that on a PCB, change the board outline, and then push that to a 3D view. Just go ahead and push everything. Now you can see all parts of our library work. Now, as you can see, making your own CAD models really takes a lot of time. And the nice thing is that some parts distributors will have CAD models available for your download while you're shopping for components. So two of the big parts distributors are Mouser and DigiKey, and they both have good EDA accessibility. You can see here on Mouser, you have this ECAD model section right here. Some have, the symbol, the footprint, and the 3D model. Some just have the footprint model. Some may not have any, like this one says you have to request the model. But for this example, we're going to be going over one of these fuses. Let's say we're making a USB device. You're limited to 500 milliamps, and look at that right here, this first one, just under 500 milliamps. Looks good to me. Go ahead and click on it here. You can see it has a data sheet, and if we scroll down here, all the way down, there's EDA models. And going back to the parts page, you can sort through different parts based on what parameters the manufacturer has specified. And there's also an in-stock option, a datasheet option, and a EDA CAD model option. So I click all three of those, and that's how I found that part. When you click on this CAD model, it should pull you to a page over here, and you can see there's libraries from Ultra Librarian and Snap EDA. I prefer Snap EDA. It's been easy for me, but Ultra Librarian's another option. There's also GrabCAD. They have a lot of different parts available as well. But if you go back to DigiKey's website, there's this select download format from Snap EDA, and we're going to use Fusion360. It's right here. Go ahead and download it. You can also download the step model if you want to change parts. So you see it downloads there. You can also right click on Snap EDA and it'll take you to their website. You do have to be signed in for Snap EDA, but you can see there's several different formats depending what software you're using. After downloading your library, you're going to want to extract the folder, and in Fusion you're going to open up your library that you're working with. Let that load. You can see we already have some parts in here, and we're going to go to Create New Component, Import, and it opens up this menu where you have a bunch of different libraries that you can use. But we're going to open Library Manager, and you would click on Import Libraries up in this top right corner, and that's where you would find the file that got downloaded and import it. I already did that, and it's in use right now. So it's this OZCJ file. So we can go ahead and close this. Find it here in this top, and we're going to click the arrow and find the part. And we can see the schematic symbol and the PCB file. So we can hit OK. And it imports right into our library. So obviously this doesn't have a CAD file. That's where that step file would come in. You could add that and manually add it to the library, but it's pretty simple. Just go on Google and search for the part you're looking for, or go on one of the part suppliers like Mouser or DigiKey, and there's a good variety of manufacturers that have that support. Thanks.